Hi, welcome back to Coding Games in Python. In this video, we're going to talk about how to clear complete rows. In the last video, we had a lab that helped us rotate a piece, and so now we're going to add to that. And so please try to do that, and then the solutions are posted. Let me kind of show you what this will look like here. So I set this up already, so I don't have to waste time. So here I have a bunch of things in memory. We did this already. We add as the pieces go down to the bottom, we add it to the board. And then we can rotate, and now we want to clear rows. So for example, if I go down here and I go down, then I should clear the bottom two rows. So that's what we want to do. Okay, alright. So here's the basic algorithm. So in the there was a do move method in the Tetris main pie of a module, and this do move method takes a direction. And so for example, do move left, do move right, do move down. And the way it works, as a reminder, is that we did this in the previous video. We took the direction and figure out what change that is. So for example, if I'm moving down, this would be dx would be 0, dy would be -1. And so extract out the vector of the movement, and then if the current piece can move in that direction on the board, then go ahead and move it. So that was the and then, but if you cannot move in that direction, so if this is false and you can't move in that direction, and that direction is down, then you must have reached the bottom, so you should add that current piece to the board. So we did that also in the previous video. And now what we want to do next is that we want to, after we add a piece to the board, we want to check to see if we can remove any complete rows. And then once we do that, then we can create a new random piece on the top. So basically we did this algorithm, and we now adding in this method. So we're gonna do this method in this video, just so we know where we are in the game here. Okay, so here's the pseudocode for this method. So we're gonna for each row, starting from the top to the bottom. When we remove complete row, we want to go from the top all the way to the bottom. For each row on the board, if that row is complete, so we want to check to see if that row is complete. If it is, then delete that row, and then we want to move all the pieces down. So I didn't show that in the game there, but if a row is removed, every row above it, every row starting at r row plus 1 all the way to the top has to be moved down by 1. And so that's then we want to add 1 to the lines counter. You want to keep track of the number of lines we clear. We can add 1 to that counter. Yeah, so in fact, you know that these are 3 methods here. And we'll do the first 2 together in this video, and then you get to do this in the lab, the move down rows. These 2 methods will help you do this last one, which is a little bit trickier. In fact, this is such an important part of the game. When I post the lab for this assignment, I will let you guys do all 3 methods, because you know, I want you to feel like you've kind of do most of the important part of this Tetris game. And so again, if you don't want to watch the rest of the video, you can go ahead and do the lab right now and try to do this all this on your own. I have a lot of comments, and the whole template is posted. So but if you want to look at the first 2 method here, and then that way you can kind of see how this is done, then you can try the lab later. So it's up to you. But let's go ahead now and go to the lab here. So again, we're trying to do remove complete rows. Okay, so the algorithm is simple. For every row so we want to go from the top all the way down to the bottom. So we want to start at the top, height -1, and then go all the way down to -1. We're going backwards, so from the top to the bottom, and we're going down by the skip is -1. So again, it's not including the endpoint, so it will be from the top to 0 basically. So for each row in the board, if I'm gonna call it, by the way, this is all in the board class, just so we're clear, right? This is all in the board class. Add piece to the board, remove complete rows, this is all in the board class. So if, again, we're gonna do a top-down approach here, but we're gonna do this method later. So we're gonna call this method is row complete. So we're going to call is row complete on that row, the current row we're in, and if it is complete, then we want to delete that row. So self.delete delete that row. And again, we haven't written that method yet, but we'll write that later. And then this move down rows here. So after I delete that row, then I move down rows, and I move down the row starting at row +1. Right? So starting with the one right above me, all the way up, we move down all those rows. And then I have a lines attribute here that I need to add 1 to. So self.lines. So lines starts at 0, and then we'll keep track of the number of lines that we clear. So yeah, so this is a top-down approach here. We just wrote this method, but now we need to go in and write the other methods, these 3 methods here. So we'll do these 2, and then you can do the other one in the lab. So I'll show you the answer to this one also. So how do you know if a row is complete? So this is given a row y, I want to know if that row is complete. So for each x in range self.width, so we're going to look at every column essentially in that row. For every column in that row, if not, x y is in self.blocks on board. So for every position in that row, if that position is not on the dictionary of being on the board, then return false, because a row is only complete when every position in that row is on the board. But if one position is not on the board, then that row is not complete. But if I finish the whole for loop without return false, then return true. So that's not too bad there. So is row complete? And then delete row. I want to delete that entire row. And so again, for each, same for loop here. So for each column in that row y, well, to delete something, let's take out the block that is in that position. Well, how do I get the block? The block is, well, let's look at the blocks on board. I can access the block of a certain position by using the tuple. So this is the dictionary. The key is the tuples, x comma y. So, and then the values is the actual blocks, the actual block sprite. And so for each position in that row, I extract that block, which is a sprite. Now I want to remove that block from the sprite list. So I can say block dot. There's 2 ways to do it. You can say delete. So in the RK library, if you call actually kill, sorry, not delete. If you call kill, it will actually remove that block from our sprite list. Or another one that is probably better is remove from our sprite list, I believe. I think that's right. I always forget. Remove from sprite list. Yeah, remove from sprite list. So that way we remove that block from sprite list, and that means that we won't see it again on the screen. And then we also want to remove it from the dictionary. So self blocks on board, and this is the dictionary, so I can call the pop function, and I pop out that key. So to remove a block, I need to remove from the sprite list that we don't see it on the screen. We also need to remove from the actual dictionary that keep track of all the blocks on the board. So that's yeah. So some of these tricks will help you actually in the next method, which is move down rows. So starting with the y start row, we want to start there and we want to move up, and every row we reach, we want to move that row 1 down. So this will move all the rows above the one that we just cleared down by 1. So this will use the nested loop, and I'll let you think about that, and then I'll post the answer. But I want to at least do these simple methods so you can kind of see how some of the basic things works. Yeah, there we go. So this is go ahead and work on that lab, and then I'll post the solutions. Okay, we're getting close to being done with the game, so this is really good.